types of the different numerical data types we have in Java programming language. Now, I earlier said that numerical data types are mostly for handling numbers like the normal 1, 2, 10, 20, and the rest. These numbers, when you're passing them to your ID for it to be processed, there are different types of data this thing. I want to explain this in a very simple way that you understand. There are different ways you can pass it to the computer depending on the size of the data you want to pass. For instance, if you want to pass 5, let's say you want to do normal 5 plus 5 is equal to 10. Normal. You will also do something like 1 million, right? 1 million plus 2 million is equal to what? 3 million. These two operations now don't have the same value. When I mean value, I mean in terms of characters. This thing now is going to be 3 million characters. The computer is going to sit as 3 million characters. Why this is just ten characters, that is 10, the value of it is just 10. When you're sending this into the computer is going to look at it as a very small value because it's just 10. It's not going to be the same thing as when you're sending this one, which is 3 million. So for you to send this one, you have to have a sort of bigger placeholder, which is a bigger numerical data type to handle it. The different numerical data type. Okay, let's start from the smallest. This is arranged in the order of the range of values, which is the size it can contain. The smallest one is the byte. The byte can handle just 128 characters, which is plus 128. The byte can handle from plus 128 to minus 128. Now, what this means now is that if you want to declare a byte value, if you want to declare byte variable, but this can only be any value between this plus 128 to minus 1. It's just like in math, in your normal math, when you have what's the name of that? Okay, I'm not understanding math. Where you have this is it number fraction. So where they'll give you a range of values and tell you that you should use only from this value to this value. That is exactly what is happening here. This byte is telling you that you can only use from this plus 128 to this minus 128. So anything outside here that you're trying to give to this byte value is not going to be valid. It's not going to make sense. Like the computer will not even understand what you're trying to tell it because it's best if you're just going far. You're just trying to give something that it cannot process at all. It has to be within this range. So now if you give it 5, you give it 5 and you close the statement, you can see there's no error sign here. Everything is good. You can give it any value between this. You can give it 1, you can give it 100, you can give it 55, any value. But once you go outside this range, something like 550 now, you can see the error sign just came up saying that what the required type is byte, but you're giving it another type that it does not understand because it's not within this range. You can give it this 128. 128 is okay. Sorry, 128. Yeah. It has to be between 127. Sorry, 127 to minus 127. It's in between the two values. So you can give it 127 and it's going to understand what you're trying to tell it that yeah, the value is 127. You can give it anything 126 in that range. You can also go minus 127. Sorry, minus 127. Minus 127. Everything is still looking good to you. You're still understanding what you're saying. But anything outside this range is not going to understand. This is the smallest value. This is the smallest numerical data type that exists. So you cannot go anything. There is no smaller range of values in programming language below this. This is the smallest. We have higher ranges. Like for instance, the next in the order is short. Short is another. You guys should be used to keywords by now. Things like byte now, byte, string, string, short, I just mentioned. All these things are keywords. You can see whenever you type them, the computer changes the color to this orange color, showing you that it's a keyword. There are a lot of keywords in Java programming language, but you still get to learn them as you go. So going back to short, the value that short is able to store, the range of values is between -32768 and +32768, which as you can see, obviously it's higher than the byte 32768 and 32768. It gives range of values for short. So anything outside these values now, the computer is not going to understand what you're telling it. Because you just know that what you're giving it is short, which is going to be between this range. It's going to make it, but these ranges have their advantages. For instance, now, if you're telling the computer that you want to process something that is in bytes within this range, it's going to be able to process it faster than something that is in short, because the range of values for this is okay. How, like, it's just like, imagine now that someone brings a room that has a lot of slots, like a lot of partitions, and tells you to go through all the partitions. If the room has only 128 partitions in it, you'll be able to go through and look into its partition faster than a room that will have 32,768 partitions. That is basically what this programming data type is all about. That's the difference between each data type. The computer will be able to process this one faster because of the fact that the range of values are smaller. They're able to process it faster than this one. So that is why it's always important to choose the right data type when coding, because it makes your code run faster, it makes everything smooth. So now this short, going back to this short, if you want to declare a short now, let's say pen, you name it pen, you name your variable pen, and you decide to give it a value of 1,000. And see it's valid, no error sign, everything is okay. The computer understands what you're trying to tell it, that the value of pen is 1,000. Let's make it 2,000. Still going to understand. Let's make it 20,000. Still going to understand that yes, the value is valid. But the moment you decide to go above or below this range, say you decide to say 38,000, it's going to give you an error that this value is too much. Oh. I don't understand what you're trying to tell me. It's too much. Calm down. Come lower. You have to come in this range of 32768, which starts from 32767 all the way to minus 32767. So you can see the difference between the two is clear. This is just 128 to 120, which is about 256 characters. Why this is a whole 32,000. So it gives you a wider range. Now coming back to the next one in line, we have int. Int is a very common, even those that code JavaScript, Python, everybody should be familiar with int, but I'll say it's the most used, it's the most common among all programmers. Int has a value of int has a value of 214,748,3648 minus 214. Let me type it out also. That plus this is the value for int. You can see it has a wider range, far wider range compared to byte and also compared to short. So if you want to declare int now, int it has to be within this range as I explained. 214,748,3648. Has to be within this range, which is plus this minus this. So you can use any number in between. You can use 2,000, 20 million, as much as like any number. So now you can come and be like 5, 50,000, 100,000 plus 50,000. It's going to give you a valid statement that yes, what you're doing is correct. The value of this book now will become what? To become 1 million. And that 1 million still falls in between this range, which is plus 214,748,3648 to minus 214,748,3648. But if you decide to now go above it, let's say you make this 5 million, this 6 million, the value goes above. Once the value goes above it, tell you that no, it's no longer valid. You can see the red outline just below it, telling you that it's not possible to do what it's saying. Then moving ahead from in, next one, you have your float long double. I think I made a mistake here. The next one after in should be long. Next one after in should be long. Yeah, so next in line is long. Long has a value of, I think the value is so large. I think it is in billion. Of this rate for long and pairing your long with long tape to form anything in the value. As simple as that, just like the other one. If I make a mistake. But moving ahead, I'll still come back to that. Moving ahead, you have float and then your double. Both of them as well used to store data types. That is in their order. After long is float. The larger the number, the higher you have to float. So after long, you come down to float, and you have your double. That's the that's the order. Order is from byte to short to int to long to float and to double. And it's important to know this order because if for instance you're coding something, let's say you're making a calculator like I said now, and you're designing a calculator, right? And you're like starting int x, which is the first value the person you type. Int x should be 5. And you come and say int y should also be the next number, which is 7. And after that, the result of the two operations, if the person wants to do its result, should now be what? X plus y. This is valid because it will be able to store the number, be able to store the number in this integer data type. But coding this type of thing is not advisable because, for instance, now if the person decides to go higher than 5, 7, 1,000, 2,000, If person wants to start calculating billions, maybe person is a very big businessman. I say he wants to calculate 1 billion plus 4 billion in his calculator, and he does something like this now, and he types it in the calculator, and he press equal to, and the result is meant to run this operation, which is first number he types to the second number he types. It won't be able to run. The calculator will just crash even. The calculator will crash because it will not understand what it's trying to. The numbers it's giving it are too big for the calculator to handle. So it's just going to crash. It's not going to be able to give him an answer, which is bad programming ethics. We're meant to use something that the calculator can handle. Give it something like float or long, something bigger to handle any range. So you know that it can handle any range. If person wants to calculate in billions or in trillions, to be able to handle it. That is where all these things come in place, and to help you avoid all these bad practices and things that will lead to error and tarnish your image. So those are the types of data types, as or just 6 of them. Then moving on from them, we have variables. The programming language, what are variables? Variables are just like it's similar to what you have in mathematics, where they will tell you social variables x and you should find x. X is a variable. That is, I'm talking about in mathematics that we all know. They'll tell you find variable x in so equation. It's the same thing in programming. It's a variable that is used to represent data for computation. Now, for instance, you want to do 5 plus 7. Yeah. Let's say you want to do 5 plus 7. You can just come here and just do. Yeah, let me create a number. You can just come here and just do int 5 plus 7, and it's going to give you your answer, which is what? It's going to be 12. You can give the computer directly that this is what I want you to do. 5 plus 7. But imagine a situation now. Imagine a situation now where the values you want to compute, the values you want to solve are not already defined. There are values that you expect, maybe you expect the user to give you or to type. Like let's use that same calculator example now. You want the user to give you an input for the computer to calculate for the person. You have to make use of variable. What is a variable? This XX here now is a variable. This result here now is a variable. Y, variable, X, variable, car. All these things are all variables. They are things that actually represent this value in this number here. So to the computer now, anytime you want to make use of a value, you have to assign it to a variable, because what the variable is what the computer is going to be using to find the value. If for instance now you assign this value, this 5 to y and also 5 to x. Okay, let's make this 50. You assign 5 to x and assign 50 to y. And you want to do 5 plus 50. You cannot just come here and just say in 5 plus 50. Not just come here and just say it means 5 plus 50 and expect the computer to just do it straight like that. It's not possible. You have to represent the data with some. What you can simply do here now is to come and say int x plus int y. What will the computer now do? The computer knows that you've already. Sorry, you have to also give this a variable. The computer will now know that okay, you've already told it before that x is 5. Okay, and that y is 50. So you're not going to compute this 5 plus 50, which are the values of the two independent variables. You're going to compute both of them and now store it in this other variable, which is f. Whatever you're doing in programming, you always have to use variables. Even in string that you were taught last week, using string, you see declare variable, string, price, in price, 5,000. You're just telling the computer that this 5,000, store it in this variable. Just like mathematics, they'll tell you 2x plus y is equal to 50. 3x minus y is equal to 15. Find x and y. That x and y is the variable. That's what you're looking for. The value of that x and y is what you're trying to tell it to find. Same thing with computer. Always working with variables. So, and storing variables, there are different type of variables. Like this is a string variable now used to store character. Why is a numerical data type used to store numbers? So it all depends on what you want to achieve. Whatever you're doing, it depends on what you want to achieve. And now, let's call these two numbers x and y. Now, see, you say in mathematics, you say x plus y and x minus y. But in programming, you have to declare the data type to be assigned to them. Each variable has the data type assigned to it. I've already said it. Each variable has the data type assigned to it. This price now, the data type assigned to it is string. So you know that the value of the price is going to be characters. It's going to be characters, which is 5,000. Character by characters here, I mean letters. That is A, B, C, D. You seeing this 5,000? Okay, let me change it to 5,000. Right. So the value of this price now is price. You cannot come and store something like five here. You cannot come and store something like five here. It's a number because of this data type. This data type is making it invalid because this is a string data type, meaning that whatever you're putting here must be letters, must be alphabets. You cannot come and put five. You cannot put 50. You cannot put any number. It has to be a string. And strings in Java are written using this apostrophe, double apostrophe. You must always use it to declare your string. David must be in between the two apostrophes. Right. For instance, then must always be in between the two apostrophes. That's for string. And the funny thing about why people are always going back to this string is because you can also store numbers as characters. You can store numbers as alphabets. It's allowed. Something like 50 now. You can just put it straight here. It will look at it as an alphabet and not as a number. You just look at it as a word and not a number. But the bad thing about it is like for instance, if you want to do 50, if you store this 50 now as an alphabet, you cannot come and start doing something like price plus. You cannot come and start doing something like price plus let's say X here. Price plus X. To tell you invalid because you're trying to add a word to a number. It's not possible. Like saying you're trying to add the word David to the number 10. It's not possible. It can't happen. You can see the error. Required type is int, which is a number, and you're providing a word, so it's not possible. But if you change this thing now to an int, change this thing now to an int, and remove this across of this thing becomes valid. Because it's going to give and what is valid? The value of this d now, the value of d become 50 plus 5, which will give me 55. This d give me 55. That is the funny thing about you can always use you can play with your variables in free time. Play with them, know how to work. If you have any questions, come back and ask. So that's it. Anytime you're declaring your variable. Data type determine what is stored in the variable. Then the general syntax of declaring variable, you should already know that by now from the things I've been typing, is data type to the left and then the variable to the right. It's evident in everything I've been doing here. These are the data types. These ones in orange are all the data types, including string. While the ones to the left, to the right of it, are the variables. Starting from here, book is the variable, plate, variable spoon, variable car. All these are the variables, and then these are their values. After the equal sign, you have the value of each variable. The value of each variable, all showing, all displaying. So now, moving on after that. Also, one thing I would like to mention that is very important, that two variables cannot have the same, that there cannot be two variables of the same name in one class. This is a class now. This is class splash screen. I name this splash screen. You can name it anything you want. But I name mine splash screen. In this splash screen class, you cannot have two variables that are bearing the same name. What do I mean? For instance, now go to code, come and type in box the number. equals to 74. Now later maybe you type a bunch of code, keep going, and later on you come down and write double box equal to 50. It's not going to work. Computer is not going to accept that. It's going to see it as broken because it's going to tell you that you've already told me earlier that box is 74. And now you're trying to tell me again that the same box is 50. It doesn't make any sense. Even to you as a human being, it doesn't make any sense. One thing cannot have two values. So when you're naming your variables, you have to give them different names, and it's advisable to give them unique names, names that will help you remember when you're trying to. Because along the line, coding is something that you'll be doing a lot. You'll be having different. You can have up to 1,000 lines of code, And let's say you're coding down the line and you want to come back and use something, you start scrolling all the way up, look for what you see it at. Try to save, values with variable names that are easily rememberable, that they are easy to remember, in the sense that you don't have to start scrolling up to find it. That will make it easier for you. For instance, this box now that is giving an error sign, you can simply change it to box with double X. You can see that it's not the same thing. Box with one X and box with double X are not the same. They are two different words altogether. This one is box. This one is box. Double X. You can try to think another thing. Table. One value. Meaning. One value. Anything you can. But you cannot name something with a new name. Or something like box. Something like X. I've already used X here. You cannot use X again. Not use Y again. You cannot use F again. All these things have already been taken. So you have to choose another name for the value. These are easy ways to avoid errors in your code while code. So you can see here, I guess some examples. Int X is 5, double plate is 15, long spoon is 82, then long cutlery, which is a combination of a plate and spoon, is equal to 82 plus 15. Plus 15. So yeah, it's possible because you've already earlier stated here that box is 74. You stated here that box is 74 and that spoon are 50. Spoon is 50. You already used spoon for that is why. And that spoon is 50. So if you want to calculate the total amount, you don't need to come and start doing 74 plus 50 again for it to give you your value. It will still give you your value, but to make things easier, since you already assigned these values to variables earlier, which are these box and spoon, just simply type here box plus spoon. Computer understand what you're trying to tell it. You can say I use double. You have to use double. Computer understand what you're trying to tell it, that what you want to add here is the value of box and the value of spoon, which you've earlier stated are 74 and 50. 74 is for box, while 50 is for spoon. So to just come and find this box, where did you declare it? It will go up and find it, see it here. The value is what 74. It will impute this 74 here. It will place 74 here. Go back again plus spoon. Where did you declare spoon? Declare spoon here. The value is what 50. To impute it here to become 74 plus 50, and to give you that the total value, and store it in this total variable. Because variables are like memory spaces. You can look at them as memory spaces, that once you're creating this total, you're creating a memory space like a folder in your phone, that whatever values after this equal sign will be put in that folder, in that total value, that value, and stored there forever unless you want to change it. So that's all about variables. You have other data types. Other data types in programming, like your boolean. Boolean example. Boolean is just a very simple data type. Boolean is used to resolve. For instance, you have a situation where you're told to choose between two options, this, or this and that. That's where Boolean comes into place. Boolean is usually true. Boolean can be either true or false. Those are the two values for Boolean. It can either be true or false. It can't be anything else. It can't be a number. It can't be a string like string false. It can't work. It can't be a number like 20. It's not possible. Nothing else can work apart from these two keywords, which are true and false. So it's either true or false. This is Boolean is used when, for instance, you have a conditional statement. Let's say now you want to go, um, you want to go to a store to buy something, and you have a brother. Or let's say you have a twin sister. You guys are identical, and it's hard for the person to identify who is entering the shop at a particular time. If you're told to code something to identify the person, what you can simply code is if this person passes through this door, and let's say you obviously the two twins won't have the same height. One can be 50 centimeters, the other one will be 2 centimeters. You can simply say if the person that walks through is 50 centimeters, make this, let's say let's say let me call it twin. Assign the value true to this twin. If you tell that it's so person, person can be something like Chidinma. Tell that it's Chidinma. But if the person is 50, not 52, if person is 50 centimeters, person is 50 centimeters, then let it be false. You still learn conditional statements later on. Conditional statements will help you a lot. Things like if else, try, try catch, a lot of things. It will help you simplify your code and make it easily readable and understandable. So that's what Boolean is basically. Just a true and a false statement, nothing more. And then coming down, we have arithmetic operations. Arithmetic operations, of course, everybody did math. You know what arithmetic operations are: your addition, subtraction, multiplication, division. These are all arithmetic operations. You can use arithmetic operations with your numerical data type. Like here, I said x plus y. I've been using plus all this while, self. Just plus plus plus. You can use other operations, things like x divided by y. You can use x divided by y. You can use x minus y. All these things are arithmetic operations. All these are arithmetic operations. You can use x plus y. Any of them. But of course, you all know there are different uses now. Plus is to add two values to tell you 5 plus 50, which is 55. Subtraction minus is to subtract the values with 5 minus 50. 5 minus 50 is what? Minus 45. Or you can make it 50 minus 5, give you what? 45. 50 value 5. Then the multiplication, we all know 5 times 50 will be 250. And then your division, 50 divided by 5 give you. So let's try, okay, let me print out the statement so you guys understand what I'm saying. Let's try and print out the values of this statement. Give me a minute. Let's print. f here, which is y divided by x. Excuse me. My phone is having an error. It's having an Okay, you can see here the value of name which we stored here name as Ben. Ben. We assigned Ben to name and then printed it. You can see it printed here. If you change it to let's change it to Ben down. You run it again. You run it. On zero. You can see the value here now is going down. So that's it. Whatever you assign to it is always going to be saved in the variable memory space, and then you can use it to operate whatever you want to operate. So because we are trying to display the value of this y divided by x, which is 50 plus 5. Another thing, the reason I'm using log here, normally your previous class they taught you system dot print print in. System dot print in is also used. But the reason I'm using log is because this is Android Studio. I don't know if you guys recognize it. For those of you that know it, you know that this is Android Studio, not IntelliJ. Yeah, I decided to use Android Studio for this class. Maybe next class I'll use IntelliJ. And in Android Studio, you cannot make use of system.println because Android Studio works in such a way that you have to run it on your phone. Anything you're running is being transferred to your phone immediately. That's why you can see my phone is being displayed here. So if I unplug my phone now, I won't be able to run anything. And for you to print to your phone, you have to use this log statement. You can't make use of system.out. People that will venture into mobile are the ones that will need this knowledge. And that's why I didn't want to start going deep into it. But if you want to learn mobile development, that's when you need to know this. But for your normal back end, you don't need to know this. You won't make use of it at all. That's the reason why I'm using this log so that you won't be confused. So you can see here the value of f, y divided by x, which is 50 divided by 5, is 10. You can see the result here, 10. You can still do anything you want. Let's make this 500. 500 divided by 5 and run it again. Run it. You can see the value displayed here. 500 divided by 5, which is 100. So that's how it is. Even this boolean now, display the value of the boolean. You can't print the value of boolean. So that's be your integers, double, long, and your string. Your boolean is only used for your conditional statements, like things like if swing is this boolean, then then you can write a line of code out of it. But this will be taught later on. Please, I'm going too far. Go too far. So we'll come to the end of this class for the time. I don't know if there's any other thing I need to explain in depth. Value 12. This is x. 7 plus 5, 12. For this total, which is box plus spoon that I was telling you guys about. Going to give us the value of this box, which is 74 plus 50, which is 124. 124. The value of this total here that's stored in total as a form of double. You can see it's 124.0. Okay, so I think we are done for the day.
Okay. Okay. That
Yeah,
was
Shadow, I see here.
yeah. Okay, just Michael, you can
Can
just
anyone hear me?
yeah, you can just show that page again you're talking on. Michael, I think you can hear me now. You can just
Yes.
show just share that screen again, that your Android studio. That your stuff you're just showing now. Let me just kind of summarize it for let me just say something. You understand? Are you okay? You're sharing your screen, Abby? Okay.
Yes.
Okay, calm down. Let me just enter into something. Okay, so what he was trying to say is that what I don't know if you have watched the last video that we posted, if you have watched the last video that we posted, or if you attended the last class, anyone, what's the instructor today, Michael, was trying to talk about was that he was teaching numerical data types. Just forget about that name, numerical data types. What he was just teaching was how to do some operations in your editor, how to code some operations in the sense of how to do operations like plus, minus, add two numbers, subtract two numbers, times two numbers in Java. You know, as I said, that it's just like you doing it in English. Maybe you can say 2 plus 2 is equals to 4. You know that one in English, but now when you want to type it in your computer, you will not just write 2 plus 2. That's what he was saying. He's not trying to now tell you people how if you're going to write it now in if you're going to write it now in Java, if you're how you're going to write it. That's what he was okay, that's what he was saying. If you're going to write it in Java, please, this person I just entered, mute yourself. If you're going to write it in Java, this is how you are going to do it. This is how you are going to do it. You will not just type for the computer 2 plus 2. If you look at the screen, I don't know if you can look at. I don't know. I'm trying to zoom the screen, but I don't know why it's not even responding. I don't know why it's not responding. Okay. If you look at where he shared his screen, You can see where he was talking about string, he was writing int, he was writing double, and all whatnot. If you're in the class that last time, if you're in the class that last time, you see where I said for you to declare numbers, you have to first of all put a data type in front of it. That means you are telling the computer that, see, this thing that I am about to declare is going to contain a number. It's going to contain a number. That's why maybe now you can see int something equal to this number. If you look at his something very well, you can see int something equal to this number. Then you can see where he wrote string then name equal to Ben, that type of thing. String name equal to Ben. He's trying to tell the computer that, see, this variable name is going to contain Ben. This variable name is going to contain Ben. It's just like what you did in the last class, but now he's just trying to enter, he's just trying to display, he's just trying to enter into it very very well. And then you can see where again he was talking something about boolean. If you're using the boolean data type, he was saying that if you are going to once you're using the boolean data type, like the boolean class, you can't give it any other value apart from true or false. He gave an example whereby maybe people crossing the doors be like, okay, did this person cross this door? True. Either he did it or he did not do it. You cannot give a variable that you like. Now you cannot give a variable that you declared of a boolean data type, that you declared of a boolean class. You can't give it another name entirely. You must give it either true or false. You can't give it a figure. If not, it's going to give you an error. And you can see on that whereby he was changing, he was doing some arithmetic operations. Then at that last part where he wrote string dots of something, he was just trying to convert. He was just trying to tell you that in also data types, you can convert from one data type to another. You can convert from one data type to another, whereby he was saying that you can convert, if something is in figures, you can convert it to string. That's what he was saying. That is just a summary of what he was trying to say. This class is going to continue from Wednesday, and as we said, we are still going to upload the videos, but because of um so as we said, this class is still going to continue from Wednesday, and we're still going to upload the videos. So because of those that have not paid and those that have paid, that's how we're going to do it. But each and everyone is going to receive the video if you want to receive the video. And okay, before I go, there was something again he mentioned in the beginning, if you're with us, if you can remember, whereby he was talking about bytes, shorts, ints, strings, floats, and double. He was just trying to tell you that if you're using shorts, that there's a range of values that you can declare a variable to. Like he was just like, how will I put it now, is like in an order of, will I say, like, how will I put it now, maybe you cannot store something now using bytes. Maybe you use figures that reaches up to 16,000 figures. I don't At the time, I'm just trying to put
Okay.
he was just trying to give the
Okay.
range. Okay, he was just
Pero
trying.
pero sungguh no dalam apa link.
Please, just anything you want to say,
Hmm.
can you write it in the chat box? Mute yourself, please, Victor. He was just trying to say that if you are using bytes, there's a amount that once you exceed it, you cannot assign a byte data type to. Example, now if you say byte x equal to 2, maybe it's possible, but once you pass, maybe if you say byte, I'm just giving an example. Maybe you say byte x equals to 122, the computer will assign it for you. But maybe once you pass 127, you know that that byte now cannot still contain, like byte now, their variables now cannot contain a figure more than 127. There is a higher range, so you will use something higher. So that's just the summary of what I was saying. Once again, thank you guys for participating with us, and we're still going to upload the videos. So thank you very very much. See you next time. See you on Wednesday. If you have any questions, you can chat me on WhatsApp. And remember, Connect Academy, be very consistent. Please don't quit. There's a reason why I'm telling people. Thank you very much.
Well, you only need the light when it's burning low. Only miss the sun when it starts to snow. Only know you love her when you let her go. Only know you've been high when you're feeling low. Only hate the road when you're missing home. Only know you love her when you let her go.